Tells you by mass what percent of each element is present in a compound. And this can be super useful, but just for our purposes, a couple examples where maybe in everyday life you run into percent composition would be when you get home from school and maybe you open up your favorite bag of potato chips, or maybe you get out your Girl Scout cookies. And if you take a second to look at the nutrition label, that really reminds me what percent composition is. So if you look at the back of your Lay's potato chips and you see maybe total fat would be 22%. So 22% of your Lay's potato chips is fat. 18 is cholesterol, and then 19 is carbohydrates. And then you can even see underneath that maybe those different carbohydrates are then broken down into types of fiber and sugar. So when I think percent composition, I really think of that snacky food I have after school and what the nutrition facts are. And another one that came to mind was the penny, and how after 1983, the penny was only 2.5% copper, while before it was actually worth something. It was worth 95%, or it was made of 95% copper. So those are just a couple everyday examples you might run into. But in chemistry, the main question here is how do you find percent composition? And so what you're going to use is this equation right here. So percent composition is equal to the mass of an element in the sample divided by the mass of the entire sample times 100. And so an example question I might give you is water has an overall mass of 18 grams. It's composed of 2 grams of hydrogen and 16 grams of oxygen. So how are you going to use this information to get percent composition? So the way I set this up is I write percent. Let's do hydrogen first, and then I have my percent of oxygen. In order to find percent hydrogen, I'm just going to take the amount of hydrogen in my sample, which looks like it's 2 grams, divide it by the mass of the overall sample, which is 18, times it by 100, and I get 11% hydrogen. And find the percent composition of oxygen in my sample of water. It would be 16 grams divided by 18 times 100, and that would give me 89% oxygen. And if you really want to check and make sure that those are correct, since it's percent, those percentages should add up to 100. So if you just want to check your work, you would do 11 plus 89. That equals 100. So I check it off and I'm good to go. If it didn't, then I'd go back and I'd just make sure that I rounded correctly, or check and see if I did round incorrectly, why I got the answer that I got. Another example problem would be, what is the percentage of carbon and oxygen in CO2? And hopefully you notice already that this is a little bit different from what we just did. I haven't given you the masses. And so what you're going to do is you're going to have to figure that out yourself. You're still going to use the same equation, but you're going to have to figure out the mass. And what you're going to use is the formula mass. And if you don't have a periodic table with you, make sure you go get one, pause the video and go get one, because what formula mass is going to be adding up, using the periodic table, the mass of CO2. And so in CO2 you've got carbon plus 2 oxygens, and that gets you overall formula mass. So carbon has a, if you look at your periodic table, a mass of 12.01, and then oxygen has an overall mass of 16. And if you add those both up together, you get an overall mass of 44 grams. And just for this example, in general, you may want to do this as well, but the total amount of carbon in CO2 then would be, we'd write 12.01. And since there's 2 oxygens, the total amount of oxygen that makes up 44 grams is going to be 32. 2 times 16 is 32. So keep that in mind, because when we go to do the percent composition here and use our equation, the percent of oxygen, and then we'll do percent of carbon. So percent oxygen is just going to be the mass of the element in the sample. So I'm not going to use 16, I'm going to use the total mass, which is going to be 32 grams, divided by the overall mass of my sample, which is 44 grams, times 100, and I get 73% oxygen. So by mass, 73% of CO2 is oxygen. And if I do carbon, I'm going to take the 12, because there's only one of them, grams, divided by 44 times 100, and I get 27% carbon. So this is my percent composition. If I want to check myself, I look at my percentages here, and they should add up to 100. 73 plus 27 is equal to 100. So I got it right. The one other type of percent composition question I may ask you is to find the mass of an element in a sample. And it's also important here is that if a mass isn't given, you're going to calculate the formula or molar mass of the compound and use that. So in this example, I do give you the mass. It is given, and it's 88 grams of a sample of CO2. And the other thing that makes this kind of tricky is that you have to find the percent composition before you can actually find the mass of carbon or oxygen in an 88 gram sample. Sometimes it'll be given to you, other times you have to calculate it, but make sure that you have this information first before you dive into plugging things in your equation. So since we just did the percent composition of CO2 and we are looking for the mass of carbon and oxygen in an 88 gram sample of CO2, the way I'm going to set this up is I'm going to apply this equation here. So I'm going to use a little bit of a different equation. So I'm going to find the mass of A, and then let's just do the mass of oxygen first. The mass of oxygen, and then we'll have the mass of carbon below. So to find the mass of oxygen in an 88 gram sample, we're going to take the mass percentage of oxygen, which is going to be 73%, percent composition, divide it by 100%, and then I'm going to multiply it by the mass of the sample given, so 88 grams. So 77 divided by 100 times 88, and I get 64. Percentages have canceled out. I'm left with grams of oxygen. So out of 88 grams of a sample of CO2, 64 of those grams are made of oxygen. The mass of C is very similar, except we're going to use 27% divided by 100 overall times 88. And that will be, if we plug in the calculator, 24 grams of carbon. So out of the 88 gram sample, 24 of those are carbon. So this is how you do or find the mass of an element in a given sample. And if you want to check yourself to see if it's correct, what you want to make sure is that these numbers here, the masses, add up to 88. So 64 grams plus 24 grams equals 88 grams. So we are good to go. We're correct. And just as a quick little reminder again, if the mass isn't given, just find what the molar mass is and use that as your mass instead of 88. So I would have used 44 grams. And so I would have plugged, instead of 88 here, I'd put a 44 there. And so that's it. Thanks for watching.